Hello and welcome back to another episode of Learning Rust with GitOxide. Hello Sid.
Hello, Sebastian.
Good to be back with what we left last time. What did we do last time again? What was this about? Looks funny.
Iterators.
Iterators. Big topic. Must be the third session or so. I think this was about BIREF and ownership and errors and options and filtering.
Errors, options, results, and collect. Yeah,
collect.
Exactly.
Yeah, collect was the big topic. Okay. It's interesting, when you see code that really doesn't tell you at all what you did last time, then yeah, okay. I would have expected to collect here somewhere at least, but that's fine. Because today I want to skip ahead and do the last thing that is very interesting and powerful about iterators, which is chaining and flat mapping. And I've got a very nice example here from a tool we all use every day. It's Cargo. And this code actually runs when you execute pretty much anything. So that's part of the initial setup where it checks what kind of compile kinds or compile targets you have. So for, this is for cross-compiling effectively, but also your host has a target name that is in here somewhere. And what this thing wants to do is it wants to go through the manifests of the workspace that you're currently dealing with, the cargo toml files essentially, and find mentions of all the compile targets that are available, because they have to be processed later. But first you need that list. And that's a lot of locations. And all of these locations are effectively searched in this wonderful chain blob, which is actually understandable. It's amazing, but it is, if you would write that out in imperative style with for loops and so on, I think it would be harder to read. So it's really useful to know about chain and know about flat map. Yeah, I don't know. Maybe we go through this just once, and if I say we, I think you can give it a shot, and I help where needed.
Totally, yeah. Okay, so first of all, obviously we convert it into an iterator, which, not an own iterator, but it references the values. Then copy it. I'm not sure what that does.
Look at this. Actually, you see it here. IntelliJ tells you this type is in here, and then after the copy, the ampersand goes away. So it's basically a way to own things.
Okay. So okay.
Yeah. So compile kind is a copyable. It's a very simple little enumeration. So this is starting out as a slice, and compile time here has the copy trait. And this is why you can just copy it cheaply, and it's fine.
I see. So instead of into iterator, which would own or basically move the iterator, you basically copy it with that. Okay.
Yeah. I think into iterator, I don't know if you can do that here, because that should, it probably doesn't copy automatically. Yeah, see? So that also gives you just borrowed
I see.
ones. Interesting.
Yeah.
Okay. And into iterator, you can maybe even do, because requested kinds is not used later. So you can consume the slice, but that doesn't change anything interestingly about the content, because you still don't own that. And you can't own it because this is just a slice, which always, it's always borrowed here. So even though what's inside is owned, this will never, rip out the things that it slices into and take it from there. It can't do that. So this is why.
All right. So this is again the difference between the type that is inside the iterator and the iterator itself, essentially.
Yes. I think there's also cloned here. In this case, it has the same effect. But if you can copy, you should copy and just make this clear. That this is, because that tells you as a Rust programmer, this is cheap. This is potentially expensive. But everything that implements copy also implements clone. Therefore, both work here. But you should use the more specific one. All right.
Yes. Cool. Yeah, and then the next one, chains. So I'm gonna take a guess here that it basically just attaches another set of or another iterator onto the previous one, right? Kind of concatenating two iterators.
Yes. And that's exactly it. I mean, if you explain something by using exactly the same word, it chains two things together into one. It basically two sequences that are iterated on are becoming one sequence. I think this is how you can imagine chain. And of course, there's no limit as to how many chains you can have. I mean, there is a limit, but I think you don't hit it with manually written code. Because there's a limit for type depth, I think, and this type gets more complex every time you hit you nest something there. All right, so now it's probably time to maybe make this more approachable. So this inner iterator, right? So now we pull this apart and say we chain essentially just two iterators, but let's understand this iterator a bit better that also uses flat map, and that's a bit new. But let's see. Okay, up to you. Back to you.
Yeah, so members, I'm not sure, probably returns, must return an iterator, right?
Yes, yeah. Impl iterator. I don't think we have seen that a lot. It's an easy way to say that this implements an iterator, and it's something that we don't further specify. At compile time, the compiler will know the exact type, but you don't have to write that type, and that's what impl iterator does. Because writing a type that has a closure is impossible. Therefore, having an iterator in as a return value needs impl iterator. This is why this is used here. Okay, so outcomes.
Okay, so we get an iterator there. And then, yeah, the flat map. I'm guessing that this is, I mean, this is again like the filter map, right? This is kind of two operations in one. And the flatten itself, I'm guessing, deals with nested iterators. So it kind of packs them into one level of iterators, essentially. And then you map over that.
Okay, so let's just assign names to stuff. Flat map, so that is other iterators, or per package iterators. So for each workspace member, which is a package, we get another iterator. This is why here in disclosure we see P, which is a package. And a package is basically what you have in your cargo toml. That's the manifest with lots of additional information. So this essentially just says, give me all the manifests of my workspace members, and then I do something that gives you an iterator for each of these manifests. So here, that's an iterator of iterators, which is flattened, which means it's like an automatic chaining. What does the documentation say? Create an iterator that works like map but flattens nested structure. So that can do a lot of stuff, actually. It's probably worth reading this. The map adapter is very useful, but only when the closure argument produces values. If it produces an iterator instead, there is an extra layer of indirection. FlatMap will remove this extra layer on its own. You can think of FlatMap as a semantic equivalent of mapping and then flattening as like in map flatten. Okay. So we get, and this map here is the package, and we map that into an iterator, and then we call flatten on that iterator. So does that mean there is something? Ah, yeah, see, we can flatten on an iterator. So if you happen to have an iterator of iterators, you can flatten that into a single iterator of items. And this is both combined, right? So it's just we can write that one after the other if you want to. We can say map and we can say flatten right after. Flat map is the combination of this.
Yeah, okay. That makes sense to me.
Okay, so then this is more like iterator. It's a package compile kinds iterator. Because that all this is about compile kinds here. So whatever comes happens in there must produce an item that is a compile kind. This is then all compile kinds. So that makes sense. Okay, so now we can, just study this further and see what happens here. So package manifest. Oh, now
yeah, so you
IntelliJ.
check the manifest of the package. You generate a default kind. So if there's none present, I'm guessing.
I undo this because I think then I will keep IntelliSense here. Now I can jump there if you want to. Before that, I couldn't do that anymore. And here now we have types. That helps, definitely. Because you need
that
to,
helps.
Yeah, definitely. So, okay, so we get a manifest, and then there's some default kind, okay, which is an optional, by the way, optional kind. But it's a kind that we have to see, okay. So single kind or no kind. Interesting.
And then you turn that option into an iterator.
That's...
Okay, so that only executes if we have some. If it's none, then it'll stop right there.
Yes, or it will be an empty iterator. Which is cool. So every option, there's something to remember. Every option can be an iterator over one thing or over nothing, depending on what the option variant is. And that can be useful because now they work in contexts where an iterator is expected. But you happen to have only one thing, no problem. Put it into an option. Like literally, if you have only one thing, just say, okay, here you have something, and anything taken an iterator will happily work with that. All right, so now we have an iterator, and it's good to see that here as well. That makes it so much easier to follow. And we chain that. Okay, what's next?
Chain that. You chain another kind onto that, forced kind. I'm guessing these are two things that are, or should be, or are maybe present in the manifest. So default and the one that you want to, I don't know, forced. Not sure what that means.
Yeah, me neither, honestly, but doesn't matter. It's more about what happens here on the iteration side. But what I see is that we have two individual items that may or may not be there, and we just put them into a sequence using a chain. And even if the first one isn't there, but the second one is, this will still work because that chaining will just say, okay, one iterator is empty. Now I go to the next one, right? And if that's empty too, then you go to the next one. And you deplete each of these, and then chain goes to the next one. This is what chain does.
Okay, so it doesn't actually stop when the first, like when the default kind is none, it still chains the second one. Okay.
Yes, and only when the second one is depleted, then, it can't do anything. It only knows two iterators anyway. And then this bubbles up, and eventually maybe the iteration stops. But maybe there's another chain somewhere that picks up the slack, and then, because these can be arbitrarily nested as well. Here it's kind of a flat list, though. Here we have directly on the same level, one chain, two chains, and in here, what happens next? Yeah.
Okay, so we check the manifest for dependencies, and you iterate over those.
Then we have an...
And then,
Oh, this is actually very interesting because that's what we did last time as well.
So you filter these dependencies and transform them to a compile kind.
Yeah, exactly. I mean, there's two cool things about that. I mean, first of all, like flat map, filter map, you can write that as filter, and you can, first a filter and then map. But in this case, it's so much more powerful to use filter map because that has the right return type, the correct return type. Because here, here you are in option land. That's how I think of things. So if something starts returning an option, then you are in option land, and you have to, ideally you stay there. And if filter map already is option land because it is a closure that returns an option. And that's perfect because now you can just go ahead and say, okay, if there is an artifact, give me the target. Otherwise, please bail out early. And bailing out early or using question mark operator, that works on options too. And you can just say, if there's none, return none. So early exit. And this allows you to nicely chain this very succinctly. Okay, there might be a target here. So there's an optional artifact target. And you do the same thing. Drilling down to compile kind, which is also an option. But guess what? We are in option land, so that's exactly what it wants. So it will ignore the none or see the sum, and that's a compile kind. So now we have an iterator over compile kinds here that we just chain to the previous one. That's a real iterator for that matter. I mean, all iterators here are real as far as the type system is concerned, but that at least has the potential for multiple items, whereas this is known to be only one item at a time. And yes, these are then flat mapped, so there's a bunch of iterators that we automatically put after each other. So I see flatten or flat map in this case more like a way of automatically chaining things until the iterator of iterators is empty. And yeah, so there's two levels of chaining here as well. There's the top level that just connects the initial requested kinds with the second iterator that internally has another 2 chains going on. Maybe 3 if you like a bunch of iterators, 3 iterators that are chained together using 2 chain calls.
Yeah, and then in the end,
and
what
that
you
for
end
each
up
member
with is just
yeah.
one big list of compile kinds for every dependency essentially nested in the workspace.
Yes, and the usage is exactly like that. Now we can just iterate the kinds and do something with it. And doing this is super efficient too because it's lazy, right? This is not allocating at all. This is really just going through a data structure. And that's something that is maybe easily overlooked. Like, okay, why would I do this? Well, this is why. As this is also why I think it's very readable. It's very succinct. It's easy to write, actually. It's nice to write and to drill down to things. I think it's always, options are always nice in this context. If you have any kind of error handling, I always find that a bit cumbersome because then you have to allocate. Or you have to loop over it and then, do this kind of things. Like if something here would error, then you would probably keep results in there. And then you would say, okay, let's unwrap this or unfold it. Let's just bail out here, because then you still do not allocate. You don't want to collect every time necessarily just to bail out early, because that collection is really just to not write that. So if there was a result in here somewhere, which it is not.
But you are using the, basically my question is, you could also, instead of writing this for in loop afterwards, you could also chain another for each at the end of this entire iterator thing, right?
No.
But it's probably, no?
No, for each does not exist. I know in JavaScript, TypeScript, it does exist. And it might even have advantages to have it because maybe that loops faster or something. I don't know. Optimizations. But here it does not exist. You cannot loop over things unless you use a for loop. But no, you have to consume the iterator, and for the for loop does that. You could like even though it's kind of a bit of a digression, I think it's a fun question to look into, because you can inspect values, but that only gives you a borrowed reference to what's inside, right? So that's only a borrow. That's not the same thing. Here we are consuming kind. Here we get the actual thing. Here we only get to see the kind as a borrow. And now we can do something with it. Something like that. But this is still lazy, right? Like this inspection here, this is usually done for debug printing. You can just look at things here for convenience. But now you still have to use it. And one way of doing this is, for example, to count it. Like, we are not interested in the count, but I've seen myself calling this just to, go through an iterator without writing a loop. Yeah. So would be nice to just say consume or something, and then or execute, just do it, or engage, because Picard wrote that language here. That would be something. But yeah, that's a kind of a cumbersome way to write a for in loop, because in a way that gives you many advantages to do this, because whenever you have closures, you can't do error handling nicely.
That was what I thought, yeah, because you end up in the closure, essentially,
Yeah.
you're kind of locked in. It's
Yeah.
more suited for simple things.
Yeah, you're locked in. You can't exit out of your parent function, parent method. Yeah, it looks like you have some sort of retro filter active right now because of the sun and the
sun is just in the right angle.
Yes. No, it's cool. It looks 8mm kind of style. Some people spend a lot of CPU cycles to get that. You have it for free. Nice. So, yeah, that's that. This is chain and flat map, and I think it's hard. I thought we would do something like recreate this, but recreating it would just be a simple example of exactly the same thing. This has it all, plus some extras from that wasn't so visible last time, and I just undone the changes, and that's how it looked before. So very nice. A fun fact: after the last session, when we actually dealt with closures and filter map, and I think quickly mentioned that you can do this kind of thing, like exit out of something quickly if you're an option land and have an option closure. Then I went back here and actually changed this, because this didn't look like that initially. Initially, it did look like, let's see, it looked like this. Let's see, yes. And that was my initial version of it, which does the same thing, but unnecessarily complicated, because I didn't think of the question mark.
Right. Yeah, you're still doing a filter map, and then just handles this option essentially, or disregards the null case.
Mm-hmm. Yes. Right. It's exactly the same up to the filter map. That's true. And then inside, it's very different. And then is useful nonetheless, because sometimes you are not in an option closure. And when you are not in an option closure, you can't use question mark. And then is what you want, because that takes another option and change them if something is in there, right? So here we have an artifact, and then if there is an artifact, then we take the target, and if there's a target, and that's how you chain them each time going in another nesting level, which you can do. I think you can also write things a bit differently. You can also break the nesting level. Does it allow me to edit this? Can I just forcefully edit this? I just copy this out maybe and bring it back. Like this. Yeah, so here it goes down a nesting level, right? Because we have this outer closure. And I think there would also be a way, like if you write this, then you might as well see if you can nest that differently. So now target returns an option. Oh yeah. The problem is every piece here of the chain on this level must return the right type. So every chain here needs to return a compile type, compile kind. So I thought initially maybe I can write this, so kind of flatten that nesting a little bit. But I can't, because now this option here, if it's like, even if it's none, it doesn't have the right type right now, because that has a type that is artifact target. And this is why it doesn't like that anymore.
Wow.
Yes.
Okay, so even if it's none, if the type isn't the same,
yes.
Wow, okay.
Yes. So this does not, it can't return here. It's the wrong type. Because that would have seemed nicer to me. Like, oh no, wait, maybe I'm wrong. I think last time I was wrong. No, it's fine. If it's none, it knows that it doesn't matter because the type is not in
that
there.
makes things easier.
That's better. That's better. Because I was also thinking, really? Does Rust not get that? Because sometimes I think I was confused because when you have results, then the error type, of course, is important. And then you really want to be sure that this is the right type because that is a value. But none is not, there's no generic thing in there. It's really just none no matter what. And Rust knows that.
It's always the same.
Yes. So this would be, this would be a better way of writing that, I think, when you have to write it. So that you kind of flatten this right away. And as long as you get your parentheses right, then I think you won't be confused by all the red that IntelliJ might give you. Like I was. And I was thinking, no, that doesn't work. So I just undone it and moved on with life. Because, yeah, it wasn't really worth it. But it's good to see, too, that you can always go back and make code better in small steps, even though this is still not as good as what we had before.
It's much nicer.
Yeah. And it's I can't stress enough how important it is to know your options, know your results, know how question mark works, know your context that you're in, and then you can nicely compose these things and really think of just small tiny pieces at a time. You don't have to think of the whole complex thing that it actually is. Just what are you working on next? And then also work stepwise, right? Like even if you don't know how exactly this is going to look like, you can start, like always, the thing number one, like just put this in here. I don't know what to do, but I want to see if this is right so far. Let's do that. And now you can compile and see that it type checks, which means that, okay, now you can focus on this little thing, artifact, target, compile, to compiled kind, and works. See, I just reproduced this real quick because IntelliJ also is really helpful with this, as long as it can follow the types that are in here, which often, if not most of the times, it can. So it gets better and better. So pretty neat. Then I think this can conclude our session.
I think so, yeah. I mean, I get that probably recreating or trying to recreate an example like this is probably pretty hard. And I think this was, that's really clear of what's going on.
Yeah.
Also, although it looked a bit intimidating at the beginning, it's actually pretty simple if you break it down.
Yes, I love that. Maybe you can do that more in future as well. The more complicated the things get, if I remember code that does that, then we will look at that preferably instead of rolling our own. Okay, cool. Thanks a lot, Sydney, and thanks a lot, everybody, for watching. And I hope to see you next time. Bye-bye.
Thank you. Bye.